The heck? Who was that?
Somebody
That was Trump Run's teacher.
Sounded like. Okay. Thought that was a feedback here. I think I turned off that other video. Yeah, there shouldn't be any other videos running. Conference. Yeah, that should be off. All right. And let's see. I usually do it the other way, so let me see how I'm going to do this.
Fair warning, I originally gave this talk at work, and it was for a mixed audience, so initially it may be a little more on the basic side, but just fair warning.
Yeah, that's fine. I think we're all, there we go. Try to get this in focus. Maybe. That's right. You won't see what I'm seeing here. This is Zoom presentation will be through the camera this time instead of direct Zoom. Why isn't this thing focusing now? Is there a button to, button, there we go. Okay.
Looks
Guess
good.
a focus button. All right. I didn't realize that had a button on it. Go ahead. We'll go ahead and get started.
All right, well, hi everyone, I'm Justin, and that is in fact my job title, as I'm a DevOps engineer. If you don't know what that is, you are not alone. I get asked that all the time. It's one of the track questions. So what do you do? The answer is it's a long story. Slightly shorter version is DevOps is a mix of IT and programming. So I tend to focus more on stuff like build automation and stuff like we'll be talking about today. So my talk is entitled Packer Write Once, Build Everywhere. We are not going to start by talking about Packer. We're going to go back to something I hope you're all familiar with, at least to a certain degree, virtual machines. And unless you've been living under a rock for the last, I don't know how many years, you probably know that virtual machines are kind of the de facto standard for deploying most common types of IT services. Not saying that you won't find a couple of things that still run on the bare metal servers themselves, but that's pretty uncommon these days. And there are a couple of big reasons for that. The first is cost savings. There's also ease of management and portability. So VMs do have somewhat of a leg up in those regards. In terms of cost savings, look, I've been involved in IT purchasing, and I will tell you, if you want to have a crappy server, forget having a decent or a great server, but just a crappy server, you're going to be looking at probably tens of thousands of dollars to get something that's barely passable. Hardware is expensive. So if you wanted to have, like back in the old day, 5 different servers, each running an important service on itself, your cost would be going up through the roof pretty quickly because you've got not just the servers itself, but also the rack mount hardware to hold them, the network gear, the guys to maintain all that crap. It gets really expensive really fast. And VMs allow you, of course, to run multiple OSs side by side on the same hardware, a lot more efficient. You can also do what's called over-provisioning. And if you haven't over-provisioned before, if you haven't managed VMs before, think about it kind of like this. Suppose we have 5 different VMs that each need a combined total of 64 gigabytes, but our server only has 48 gigs of RAM to spare. So what do? How do we make this work? We can't afford to buy more RAM. Over-provisioning allows you to assign more physical resources to VMs than you actually have. So each of those VMs thinks it has the full 16 gigs or 32 gigs or whatever it needs, but it's actually only given that RAM by the host OS whenever it's needed on demand. Reason being, if you think about it, most VMs are not going to run full throttle all the time. And if they do, something is wrong or you're mining a lot of Bitcoin. That can be that something is wrong. I don't know. But if they're just sitting idle, they could use a very small amount of RAM, let's say 12 gigs. Then one of them zooms up, it gets the RAM it needs, it goes back down. So it allows you to overextend yourself a little bit even further. And there's also ease of management. I mean, look, we're not living in the 1990s anymore. You don't have to point and click your way through absolutely everything. We're Linux guys. We like to automate stuff like this. And there are a lot of great ways you could do it with VMs. Everything from simple shell scripts, which of course we're probably all familiar with, all the way to more advanced tools like configuration management tools. I'm thinking more Ansible, Puppet, Chef, and that sort of thing. If you haven't used these tools, they're kind of like a more sophisticated equivalent of shell scripts. With a shell script, you write everything by hand. Sometimes you want to, sometimes you have to. But tools like Ansible and Puppet and Chef do a lot of the heavy lifting for you. It makes it a little bit easier. Security is also very good on VMs too. The isolation is unparalleled. So just because you have one VM get compromised, it does not mean the other VMs running on the same machine are going to be compromised as well. There's very thorough isolation between the two. And there's also some portability advantages too. So here's one of my key terms for the night, a machine image. And a machine image is simply a template for a virtual machine. Like a blueprint allows you to build a house, a machine image lets you build a virtual machine. Pretty simple. Most hypervisors, and that's the term for the software that manages virtual machines, come with tools to produce machine images. So like an example from where I work, we use Hyper-V. I know it's a Microsoft product. I hate it. I hate all things Microsoft. But it comes with a tool, like you can go into the GUI, you can right click on a running VM and go to export it. That way, anybody else who also has Hyper-V can then import what you export and run the same thing. So if you've got something like a product that you want to sell, or just something that you've set up for your own personal use, like a really killer media server you just love your cousin to have, you can go in there, export it, and have somebody else run it just like that. Nice and simple. So it seems to me we found something that solves more or less all of our problems, right? We know it's very cost effective. It allows us to have portability, and it's very easy to manage. So do we really need anything else? Probably not, right? Not quite. Sorry, Mario, your princess is in another castle. This is not the all-in-one solution we are looking for. VMs definitely have a lot of advantages, but there are also disadvantages in each of those three areas I just mentioned too. Cost, ease of management, and portability that you want to consider as well. With the costs, a lot of the good hypervisors out there are very expensive. Some of them are free, like the KVM hypervisor that comes with the Linux kernel is free, and I've used it, it's very good. But if you want to use something like Hyper-V or, God forbid, VMware, I thought about putting a VMware quote up here, but I didn't want to give you guys nightmares. Just take my word for it, it's more expensive than you think it is. It's ridiculous. So you've got licensing costs for hypervisors, especially in a commercial setting, like you're going to find in most businesses. There are also licensing costs for some of the OSs that you might run on your virtual machine hosts. It's less of an issue for us in Linux land because so much of what we have is free. You can get Ubuntu, OpenSUSE, CentOS, run all that for free. Maybe RHEL if you want to pay a little bit more. The main culprit here, of course, is Windows. You're not surprised, and neither am I. The more Windows VMs you use, the more Windows licenses you have to buy and pay for. So you've got costs for the hypervisors and costs for the Windows licenses too. So as you scale, so do your costs. As far as ease of management goes, like I said before, they're pretty simple to set up. You log onto your VM, you can write a shell script, and boom, it's ready to go. Great. But that's only a one-time thing. What you're going to be doing a lot more often is restarting these things, like to install kernel security updates and stuff that you really need to reboot for. And this is where VMs can be a bit of a problem. VMs can take a long time to start up. I've seen some VMs on legacy hardware at work that take as long as 3 to 4 minutes to start up. It's pretty bad. So if you have something that's mission critical that you want to just reboot very quickly with a VM, it's going to be hard to get that done quite so easily. And VMs also do have good isolation, like I said, but that comes at a hefty price to resource usage. All that isolation comes at a hefty cost to RAM especially, which can be very expensive. So you're going to be paying more for that. You're going to be able to run a little bit less because of that. And this is less of an issue on the modern hypervisors, but I just wanted to kind of in passing, you're not going to get the same performance on VMs that you'll get on native bare metal hardware. Again, not really an issue on the really good hypervisors out there, but on something like, I don't know, VirtualBox. I've had a ton of trouble running anything reasonably well on VirtualBox.
Gee, an Oracle problem. What are the odds?
And we've got a very expensive solution for you, yes. And well, our licensing people will be in touch, and our lawyers will be in touch, and we'll all work together. Right.
Surprised Oracle still exists.
I wish they didn't. I wish Oracle didn't exist, and I wish Microsoft didn't exist, but I'm slightly biased.
Oracle dented my car.
I heard Oracle runs over puppies.
Oracle takes back microscopes to hinder cancers.
I'm not surprised. There are also problems with portability with VMs. You can export things and run on the same hypervisor, but here's the problem. Not everybody is the same stuff as you. Not everybody's running VMware. We're not all running Hyper-V. We're not all running AWS EC2. So just because you can export doesn't mean somebody else is going to be able to use it. And there are also problems even within versions of the same hypervisor. So another example at work. There's a format for Hyper-V on virtual hard disks called VHD. That's the old one. The new one's called VHDX, kind of like, DOC and DOCX for the Word docs. So if we have legacy VMs, they can run on either old or new hosts. But if we have something running on a new host, we want to export to an old host, it doesn't work quite like that. The old versions cannot read DOC, they can't read DOCX either. They can't read VHDX either. This isn't insurmountable. I mean, they make tools that can convert between the different formats, but the question is, do we as enterprising open source developers or even businessmen want to make our customers or users do this? Or do we want to make them have a great experience right up front? I know what I want to do. So stop me if you think you've heard this one before.
Oh my God, you really did go there.
Yeah, yeah.
The Salford lads.
It's by the Smiths, which no relation to me, although that would be kind of cool if that was true. So I'm going to start brainstorming out loud here, our ideal solution to fix all of these problems with VMs, and you tell me if you can think of anything. So we need something that is cost efficient, something with minimal licensing costs. If it's open source, even better. It means we can have some free version of whatever we're doing that we can install on basically any major OS. For ease of management, we want to have lightning fast startup time. We do not want to have people saying, when's a VM going to be back up? We don't want to have that. And we also want to have a little bit of a lower resource usage. We still want to have good isolation because it's very important from a security perspective, but we don't want to have so much RAM use where our costs for hardware are going to skyrocket. And lastly, we want to make sure that what we have is truly platform neutral, something that runs on any major OS, whatever you've got. So if you're thinking about what I'm thinking, Pinky, you're just saying, well, gee, why don't we just use Docker for everything, right? No, let's not do that. Sorry, Docker guy, he's sad. Docker isn't right for everything. If you work with Docker yourself like I have, you're probably very fond of it. If you haven't, you've probably still heard about Docker and how containers are changing so many things. Oh, everything needs to be containerized and running in the cloud and blah, blah, blah. Well, that is true for a lot of business cases, but not for all of them. Docker definitely does have some downsides. It's not perfect. And ultimately, when you get right down to it, Docker is another platform itself. And you had to know that something like this was coming too. Classic XKCD comic. We need a solution to rally everybody else around, and now there are 15 solutions, right? There is no one universal solution, no matter how universal you may think your solution is. Both VMs and Docker containers have their strengths, and I'll prove it. So VMs are great for desktop GUI applications, like your favorite text editor and media applications, games, that sort of thing, and for monolithic applications. If you don't know what that means, think about a monolithic application as a server application that has one giant server program that handles everything users can throw at it. Docker containers, on the other hand, are more ideal for command line usage because Docker doesn't really have the greatest support for GUI tools and microservice applications. If you're not familiar with that term, it's kind of the opposite of monoliths. With a monolith, you have one giant server application that handles everything you throw at it. Whereas in microservices, you've got tons of teeny tiny little servers that all work together to do the same stuff. Docker is specialized. Docker focuses more on making things that are very small and specialized, so it's stronger at that. VMs have by far the greatest isolation. If you want the best isolation you can get, you're going to be going with a VM, no question about it. But Docker containers start up like that. A VM, like I said before, can take a couple of minutes maybe to start up. A Docker container can take less than a second. It's almost instantaneous, and it's fantastic at that. With VMs, you've got first-class support for making provisioning an easy experience, whether with shell scripting, Chef, Puppet, Ansible, you name it. With Docker containers, it's a little bit more limited. You can basically just use the equivalent of shell scripts out of the box, but whenever you do it, Docker containers are platform neutral in the truest sense of the term. The Docker engine itself, i.e. the Docker server, is open source, and it can be installed on any major OS. So whether you're on Windows or Linux or, God help us, Mac, you can still have a Docker container image run on any of those major platforms. So they both have their strengths. That's why a lot of businesses will probably end up shipping both VMs and Docker containers. They both have different use cases. Here's the thing though, we're all busy guys. Whether we're doing this on the side or for a business, we have a lot on our plate. And VMs and Docker containers each require different sets of proprietary machine image building tools. And we only have so much time to go around. What we really need then is something that can build both of these types of things. Something like Packer. Yes. If you take nothing else away from this, take this away. Packer is a command line based cross-platform machine image building tool. As far as projects go, Packer is actually relatively new on the scene. It was initially released in 2013, so it's about 8 years old at this point, kind of young. And it's an open source project licensed under the MPL 2.0. I asked this last time and I think somebody got it. So pop quiz again. Who can tell me what the MPL 2.0 license says?
Not word for word, but I believe.
You can't recite the entire thing from
I can't
scratch.
do it
I'm
like that.
disappointed.
Is
Right?
that
No,
what
worse.
is the merger of the MIT and the GPL 2.0 license?
Kind of, maybe, sort of. It's like a weak copyleft license. The code that HashiCorp itself makes is copylefted. The code that you add does not have to be.
Mhm.
So it's kind of a halfway point there. And yes, it is developed by HashiCorp, which is not a one-man show with some guy wearing his pajamas in his mother's basement somewhere in the remote corner of the world. HashiCorp is a remote-first global company with over 1,000 paid employees worldwide. Great big company.
There's a lot under there.
Yeah, a lot of basements too. They also develop Terraform and Vagrant, a couple of other
Oh,
tools
yeah.
that I use at work where I am. And I know I talked about Terraform a couple of months ago. You may have seen
Yeah,
that talk as
that's
well. It's a fantastic company and I love their stuff. I just wouldn't pay for their commercial offerings. I have no idea who buys HashiCorp commercial stuff, but I'm glad they do because I can't see the value proposition. Like I said before, most machine image platforms, whether it's a VM or Docker images, have a proprietary build tool of some sort. With Docker, it's a Docker file. You've probably seen a Docker file or heard about it. It's basically just a specialized text file that you can use to build a Docker container. Packer does not require stuff like this, though. Packer supports building machine images with over 50 commands. And a plugin is simply a bit of code that allows Packer to talk to a particular platform where you name it. The plugins don't give you everything you need out of the box, though. You may need additional software as well. So if you want to use Packer to build a Docker container image per se, you're going to need to have both the Packer Docker plugin and Docker itself installed on your build machine. This allows you to avoid vendor lock-in. You have a truly platform-neutral solution for building all your stuff. And this is especially useful for products or projects that build for all the different platforms at once, of course. Some sort of a GUI application we want people to be able to demo. They're going to go to our website, get a VM and try it out. You can use Packer to build for AWS EC2, Hyper-V, VMware, Parallels, and VirtualBox, all in the same project, all with a minimal complexity of code. The one person who might not be inspired by that and want to thank HashiCorp for all their great work is the person who loves Docker and Docker files especially. I know a lot of people like this at work. They say, but I love my Docker files. They're so simple and they just work and they're shell script based and everybody knows them. And why would I want to use Docker files? Why would I want to use this Packer thing? Well, there are actually some advantages over using raw Docker files and using Packer to sort of wrap around that process. Biggest one being, you don't have to roll your own for everything. This is a lot of the same mentality if you think back to systemd versus the System 5 init back in the day when we were kind of debating that in the Linux community. With the regular init scripts, you wrote the shell script to do whatever you wanted, but you had to do a lot of repetitive work. But systemd, it has a structure for handling all your stuff that you want to do, which I personally appreciate. And I personally appreciate this as well. So rather than having to write all the build logic for everything all the time, you've got a lot of stuff baked in the box. You can also use more advanced tools like Ansible that you can't really use with native Docker files by themselves. So like, here's an example. Suppose you and I are going to build a Docker container image that's going to have some executable installed. We can both write a shell script that does the same thing, and we've wasted our effort. That's duplicated effort. Or we can use a tool like Ansible that allows us to collaborate together, write it once, and both pull it in. It's less work. We get something that works better for both of us, and we learn from both of our use cases. We may even get tips from working together like that. You can also deploy your image directly from Packer with minimal logic as well. Again, you don't have to roll your own. So once you've built your EC2 image or a Docker container or whatever you want, you don't have to write yet another shell script to push it out to whatever else. You can just say, Packer, I want you to deploy that Docker container image to this registry over here. Nice and simple. And the last one isn't really a hard advantage, but in my field, it's definitely a good thing to keep in mind. You get a lot of transferable DevOps experience. What does it mean for you if you're not working in DevOps? Well, DevOps is here to stay, whether you like it or not. DevOps is about improving a lot of these traditional processes, making it possible for us to work together more effectively. So DevOps is not necessarily just about developers and operations. It's about bringing people closer together, making sure we're able to pool our efforts and build a better community together. So by learning stuff like this, you'll be able to help us all work together more effectively. The other thing about Docker files people say, like I said, is, oh, Docker files are just so simple. Why would I want to use something else? I'm sure this is extremely complicated. Actually, it isn't. Packer uses HCL, which is the HashiCorp configuration language. It's easy like Bash, but it's more sophisticated. It's kind of halfway between something like Bash and then something like Java or Python on the other hand, like actual programming languages. Kind of a nice happy medium. Another bonus, HCL is also using other HashiCorp stuff that I have talked about and that my company uses, like Terraform. So if you use Packer and you learn HCL, if you want to use Terraform later, it's a fantastic tool to deploy cloud infrastructure, even if you just want to have something like a personal website or something. Oh, go ahead.
So HCL is more like a macro language where it's got like certain functions can be expanded by using built-in like expressions and such.
Yeah, and I'll show you a couple examples of that next. It's actually kind of cool how it's designed like that. But again, it's pretty simple to pick up. And if you learn something like this, you can turn around and learn something like Terraform, one of their other tools, which are very, very great tools for a lot of people's use cases too. So the distinction here is that HCL is a declarative language. If you don't know the difference here or know what I'm talking about, there are basically two schools of thought when it comes to making a programming language to begin with. There's imperative and declarative. Imperative is what we think of whenever we think about most, I'm going to do some programming type work, right? It's step-by-step code. Read this variable in, do this thing, run this loop, we're done, step by step. With declarative, you don't write the step-by-step instructions. You tell it what you want it to do, and the program itself figures out how to do that. So you don't say, log into AWS, spin up this, do that, tag this. You just say, I want this VM image to be built, and I want it to be looking like this. And it figures out all it needs to do to make that happen behind the scenes. Super cool. So how simple is this? Well, take a look at this example here. I'm going to give you a minute to take a look at this and see if you can figure out, without me telling you anything. Oh, yeah.
How's it figured it out?
Basically, it kind of maps out behind the scenes what it needs to do, and uses its own internal logic to figure out like the order in which these things need to happen. It's kind of like if you and I were doing it, like what needs to happen in order for this thing to be done? These three things, right? And then it needs to be in this specific order. So it just does the same thing that we naturally do.
It's sort of AI or machine learning.
Not necessarily like that where it learns like that. It's just more, it uses a more simple form of automation that just looks at it and does a very basic, like, where does this need to go? Like if I do it like this, is it going to succeed or fail? And it lines up everything it needs to in the right order for things to work. No, it does everything behind the scenes. You just say like, I want this Docker container to be built like this, and it just builds it for you. It's totally awesome.
What's that?
Yeah, that's a good example too. So can anybody guess what this might do?
It's building an Ubuntu image for Docker using the Docker Hub, it looks like.
Give that man a gold star, he's got it.
Mhm.
We're starting up here by defining a Packer plugin that we're going to use. The Docker plugin, of course, is we're going to build a Docker container. And then the source block there, we're going to pull in the Ubuntu Xenia image. That's going to come in from Docker Hub, although it can come from a private Docker registry if you have one. And then down there in the build section, we're not really actually doing anything, but we could. This is where we put our fancy provisioning script automation stuff.
Is JSON the only format it understands, or you have
This is HCL. This is kind of a halfway point between something like JSON and EM with its own
Oh,
language.
okay.
Interesting to note, though, Packer used to support JSON, but they're moving away from JSON now, and they recommend everybody use HCL.
Okay.
So you can still use JSON if you want to, but I wouldn't recommend it.
Why does HCL look a whole lot like, HCL looks a whole lot like, what is it, what's that hybrid of, JSON that's, human readable? HJSON, I think it is.
HJSON. I haven't seen
There's a
that.
couple of them where people have gone through, they've rewritten the spec for JSON to make it where you can actually have like comments and spacing and such. To make it, they call it human JSON.
Human JSON. Yeah, I mean, yeah, people do stuff like that. I mean, Puppet did something similar with it, with its stuff. But yeah, it's similar to something like that. They wanted to have something that was kind of a good halfway point. They wanted to make their own. Don't know that I really agree with that 100%, but it's pretty easy to use.
I noticed the one plugin that you didn't mention was anything for Zen.
You know, I don't know if it supports Zen. I'm sure it does, but I don't. Gosh, it's been so long since I've actually used
I
Zen.
think that Zen does check all your boxes though. It is independent and it is open source and it is cost effective. You can actually figure out how to run it.
Keyword being if.
Keyword.
Yeah. Well, there isn't really an official term for a Packer project, so I'm giving it a term. I'm calling it the Packer project. The Packer project is the basic unit of Packer code. And all that is basically is a folder that contains a number of HCL formatted files, all ending in .pkr.hcl, and any provisioning files like a shell script in a folder. So just a folder with your build files and a script. Pretty simple. Ideally, a Packer project ought to create one type of build. So like if we have our product A, we can have a folder that makes stuff for product A. We don't want to have it make builds for both product A and product B. Here's something what this might look like. So for our hypothetical product A, again, I'm being very creative here, obviously. We have our product A images folder. We've got 4 files in there. The top 2 are for building for EC2 and VMware. So a virtual machine image template that a machine image that has our product installed on EC2 and VMware. Those 2 rely on the third one there, the install_product.sh. That's a shell script that just installs our product A. It works in either VMware or EC2 or anything else we want to build for, honestly. And the last one is just a basic settings file to find stuff like what plugins we want to use, like we saw in the example before. So not all that complicated.
How does HCL test for what, where it's going to be, which type it's going to be on? Does it like detect something when it gets there?
Yeah, basically it reads in all of the .pkr.hcl files and it kind of merges them all together, figures out what needs to be done, and it does that. And there are a couple of different block types that allow it to do that. There are 5 different block types here. And if you can get these 5 different block types down, you can write Packer builds like that. It's not a complicated tool to use.
Can you link files with the Packer? So can I have like, say, one file that specifies definitions that both apply to EC2 and VMware, and then have it read from that and then execute 2 different separate tasks?
Yeah. I typically separate them just because I used to be a tech writer and I always have like this mental image of like everything has to be separate and documented, but
So I could have something for like, say, I'm running 2 different, like I'm running Docker and I'm running VMware in a corporate environment, and I want to be able to add like database credentials or AD credentials. I could have one thing that defines here's where you're going to pull your credentials from,
Oh,
the
yeah.
credentials you're going to define, but then it can fork off and go one way for one task, one way for another task, and the 2 will make 2 different packages.
there is a way to do that, although it's not quite in the way that you're thinking of, because Packer has a very limited set of conditional logic. But there are ways to get around it, and I can show you an example of that later.
Let's say this, can you deal with salt stacker?
Mhm.
Can you deal with salt?
Oh, yeah, there's a salt provisioner.
Oh, good.
So you can use any particular configuration management tool, any major one, I should say, that you want to provision with this. It's really flexible like this. So these 5 blocks here I'm going to call the fabulous 5. We've got source blocks, build blocks, post-processor blocks, a Packer block, and variable blocks. I'm going to go over each of these and show you an example of each one. Then at the end, I'll show you a sample project and a sample build that actually uses all this stuff.
Which of your fabulous five would you insert security on?
Security stuff. Well, it's probably in the build step because you're going to want to provision your machine, right? And have whatever security stuff you want to do to protect it in there, like a shell script or whatever. So the first block we've got is a source block, and that simply defines the machine image platform we're going to build for. We want to build for Docker, AWS EC2, VMware, what? There are also certain source-specific configuration settings. So depending on the source, you may be able to set additional options as well. I typically deal with Docker and EC2, so I've got a couple of examples of these here. So for Docker, for instance, if you want to pull in a certain Docker Hub-based image, like we saw in the example before, with EC2.
How about Azure or Google?
Yeah, you can build for that too. Mm-hmm. Yeah, it supports all major cloud platforms and even some of the smaller ones too, like let's see, Linode, Hetzner, DigitalOcean. Yeah, you can build for DigitalOcean using Packer. So it has a lot of stuff for big platforms and small platforms alike.
How about a company's local?
Companies look like,
Local. Their own setup.
oh, well, if you have some sort of a bespoke setup, you're probably going to have to write a plugin for that. But they do have pretty good documentation on how to do that. So for the very, very small players like that, you're probably not going to have a Packer plugin. For everyone else, if there is a decent chunk of the human population using your thing, and there is probably a plugin for it already.
This might sound like a dumb question that kind of flows from that, but can it deal with fixing TFTP servers?
What type of server, sorry?
Pixie and TFTP, you're actually deploying to hardware
Oh.
that has these happen. So
I don't think it's typically a good use case for that. This is really just more building the machine images. If you want to image after that, you would probably use something else.
gotcha.
So it doesn't really give you the ability to back up. It's just really to build the image
It's
to
not
start.
Right, you're just building the blueprints, you can
Mhm.
copy and paste using something else.
Mhm.
And some of these make that easier too, like for EC2 here. If you're not used to using AWS, EC2 is the virtual machine service. And typically a virtual machine template will live in only one AWS region. And there are many, many regions globally. So typically you would need to build the template in one region to have it copied into all the others. With this here, you just give it a list, and it'll make image builds in the other regions as well. You don't have to copy and paste. It's nice and simple. Not only that, just the way that it does stuff with EC2 is amazingly convenient too. You can have pull in an AWS, an existing VM template. It will create that. It'll make security credentials. It will remote into that. It will generate a firewall to protect it from everything else but your computer. It will do that. It will save it. It's super amazing what all the stuff it abstracts away. It's just super awesome.
Resource collaboration.
That's right.
What is it?
The fundamental unit in AWS is resource groups. It's not your machine. It's who will be allowed to use it.
Yeah, security groups.
Yeah.
It makes its own security group, its own SSH key. It remotes into the machine with that. It protects it from everybody else, so it does it very securely. Stuff that would take me, I don't know how many minutes worth of pointing and clicking. And you can customize these with variables or consensus inputs. So here's an example here. Not really too different from what we saw earlier, but a little bit more sophisticated. Excuse me. So at the top here, the image directive says we're going to pull in this HashiCorp Terraform image from the Docker Hub. The variable syntax there is for inline variable insertion. So I have a variable called Terraform_version. I'm going to insert that there with the $ curly brace var dot and then the variable name format. So we're going to define some sort of version of that to pull from. I'm going to set commit to true so that whenever it pulls this in, it will commit it to the local computer, to the local build server, so it can then push that to some other registry whenever we're done. And the changes directive contains any Docker file formatted settings that we want to change about the Docker build. So if you know Docker files, your stuff is sort of a drop-in improvement here with Packer. We can set the entry point. We can also set this user here. Next up, we've got build blocks, and you can do your security stuff here too. This is where you can have a build block call an arbitrary number of provisioners. And a provisioner is simply a Packer plugin that configures a machine image in some way that was already specified in the source block. So step one, You say, I want to build for Docker, VMware, whatever. Now it's step 2 here. How are we going to customize this? There are a couple of different provisioners here. I've had my top 3 here, but there are additional ones, like there's Salt, there's Puppet, there's Chef. But my top 3 are here. For the shell, you just copy over and execute a shell script, nice and simple. For the file, you can copy a file over, maybe some package or some zip file you want to do Ansible code. And like source blocks, these also accept variables or constants as inputs. This can be in any order that you want. So you can say, I want to run this shell script, then copy over this file, then run this Ansible code. You can even run multiple different Ansible code blocks if you want to, multiple shell blocks, whatever you want to do. It's an arbitrary number of all these. Here's an example of that. We've got one build block here, and we start by saying, which source are we going to pull in from? So remember, we defined that Docker source called Terraform. We're going to pull that in here. And we've got 2 provisioners lined up here.
Oh, here's my question.
The file provisioner copies over an encrypted zip file that I made that contains an SSH key pair that gets copied over into the container. And then the shell provisioner actually runs a shell script that I've just written in my repository too. And I'm specifying a couple of environment variables I want to pass into that. So I can define these variables in Packer and then pass them in to my shell script. There are also post-processor blocks. So step 1, we say I'm going to build for Docker. Step 2 is I'm going to customize it like this. I'm going to have all my software and security stuff. Step 3 is we've got this thing done, so what the heck do we do with it now? Post-processor blocks can call an arbitrary number of post-processor blocks. There's post-processors and then post-processor. They didn't really distinguish it too well. A post-processor is simply a Packer plugin that packages or uploads a machine image. I typically use these with Docker containers more especially. So like the Docker tag post-processor will tag a Docker image. Like if you want to publish it to Docker Hub, let's say. Docker push will push that out to whatever the container registry is that matches the tag. So again, you don't have to code this out. You don't have to write a shell script to do this. It just works. And like the other blocks, you can customize this with variables or constants as inputs. Here's an example of that in action. We've started with a Docker container, we've customized it, and now we're going to finish it off here. So we're going to define a repository here and a couple of tags we want to apply to it. And these are all specified as variables we can customize in our Packer build script. We then want to push it, and keep input artifact equals false means that the local build machine will delete that image so it doesn't clog up disk space. So we've spun up a Docker image, we've customized it, and we've pushed it out. And we've left no trace on our build machine. For Packer blocks, every Packer project should only have one of these. It's pretty simple. Like we saw before, that specifies like the plugin version that you want to use. If you want to build for Docker, you have the Docker plugin, let's say, of a certain version. It's kind of similar to a gem file in Ruby, something like that, where you define your dependencies and you just pull in the version of dependencies that you specify. You can optionally specify your required version of Packer as well. So if you know the Docker plugin version 1.0 requires Packer 1.2, you can specify both those in the Packer block. Here's an example of that where we have both of those. In this case, we're saying we want to use the Docker plugin. It's going to be sourced from the HashiCorp GitHub page, which is where they actually host their plugins. And we're going to allow it to get the latest version anywhere between 0.0.1 and 1.0.0. And then the required version block directive there specifies the version of Packer it requires. So something at least 1.7.0, but less than 1.8.0. And finally, we've got variable blocks. If you don't know what a variable is, I can't help you. You're hopeless. Please get out now. For the rest of you, the variables in HCL and Packer are statically typed, meaning that once you specify it, you can't change it later. If you say this is a string, you can't say later on, oh, actually, this is an integer. It can't happen in this. The variables are also global only, so you can't create a variable and say, I just want this variable to be accessed by this particular block or this particular build. It applies to everything in your Packer project.
Everything's global.
Yep, everything is global. And you can feed variable definitions in using environment variables. You can use it as pkr, var, and the name of the Packer variable. So if we had a variable called foo, we could specify that with the environment variable pkr, var, foo. Here are a couple examples of that. So we just defined the variable, the type, and the description. Description is kind of like, it's really just a comment. It doesn't really do anything. And it has the usual types of primitives: string, integer, list, dictionaries, you name it, probably has it. And I say at the top here that these particular variables should be specified using environment variables like pkr, var, and then the variable, like I said before. I don't want you to think Packer is perfect. It's just almost perfect. No, it's actually not even almost perfect. It's still kind of a work in progress. There are a couple limitations here I want you to be aware of. First one being there is no conditional logic. This is a big downside at first. So like you can't have Packer project files for every possible build variant. I ran into this early on. So like, let's say if I have a test build, I want to do certain things, but if I want a production build, I want to do something else entirely.
You can't combine that with the bash shell.
Bash shell.
And bring in, under certain conditions, bring in this Docker
Mhm.
Packer thing.
No. For that, you need to make separate Packer projects for that.
Okay.
So like in my case, I would have a test build file, then I would have a production build file. So it's not something that can't be worked around. In the future, they're going to have more HCL code introduced to Packer. Like I was saying before, Packer didn't actually used to use HCL at all. It actually used JSON. In the future, there's a couple of loops that you can use. They have ternary operators. So if this is true, then do this. If that, otherwise do that. So you can use that. And there is a count directive that allows you to specify how many of these things to make. So you could.
Any chances are a Python module for HCL?
Somebody likes Python.
I love Python too. Unfortunately, there's no way to inject Python into HCL.
No, I'm talking about making Python execute HCL, like
Oh.
having it drive for you.
That's a good question. I know that you can, if you want to use something like subprocess, of course you can do anything. But I don't know if there's a direct integration there. I don't know if there's a library that will handle that directly. That's a good question, though.
That's where you make your bones, kid.
Yep.
With you saying there's this workaround, that workaround, and what you're saying now, I would say that seems to indicate at what level of maturity it's at.
It's getting there. I'd say it's come a lot further than it has been.
All languages are getting there.
That's true.
Getting there's half the fun.
But remember, HCL has only really been in Packer as a somewhat production-ready feature since, I would say, a couple of months. So this is a relatively new cutting-edge fucking in here.
But the product itself is originally been around for 8 years.
Right.
Started in 2013, I think.
They tend to take their time and get things done a little bit more slowly than I would like sometimes, but they generally do a good job once they have a finished product.
One of the issues I think might be there is how many people, like in Europe, are developing Packer stuff.
Well, HashiCorp is a global company with over 1,000 paid
I
employees.
said your firm.
Oh, my firm. Well, there's me. There's probably a handful of other people on the team that I am associated with. There are a lot of other people in addition to that. I'd say like maybe 10 people.
Okay. Just like if you don't have an administrative assistant who files things in their way, somebody else who goes in and tries to find something, but don't understand where it might be filed because, it's how it's perceived. You can have
Right.
10 different ways in which, with no standards.
Right, and that's what I call affectionately at work a Justin problem, and there are quite a few of those. I am the guy for Ansible, for Terraform, largely for Packer, and for a lot of other stuff that we have too. So believe me, I sympathize with that concern entirely.
You're worried that one day you could be rehashed, if you will, that is sucked up into hashing. Would this be a wonderful thing or a pretty wonderful thing?
I settled just for having an intern I can use to bring me coffee. Maybe I'll get one someday.
These new companies, somebody develops something that becomes needed, but nobody's maintaining it because that guy left in 5 years. And then 10 years later, somebody needs another to take a look at it because, oh, something's happening and we depend on this.
Yeah,
Now they gotta go learn it.
it's true, but like I was saying before, Packer and HashiCorp in general makes good stuff, and their products are very, very popular, at least in the DevOps world. So I would not necessarily think of Packer as a small scale project. There are people who are more old fashioned who want to use their Docker files because that's what they've always done. But by and
It's
large,
only been in the last 5 years.
yeah. Well, DevOps moves at a much faster clip than a lot of other fields do. So like
That's a long time in the computer world.
right, and DevOps, that's like ancient.
Yeah.
Out of curiosity, in terms of the flexibility of something like Packer, because when I saw what you were going to be presenting, I immediately thought of something entirely different. I was thinking something more like packages, like
Package manager.
like D package RPM type thing.
Uh,
Can you do localized build automation with Packer? Like things that are not VMs and so it has to be the target has to be Docker, VMware, something of that.
Right, so it doesn't scale to that.
Okay, so you can't
Right.
like take like the contents of a GitHub and then like do like Jenkins or something and make it compile like a jar or a okay. Bummer.
Nope. Although if you've got something already, but if you've got something already made, you can import that to a machine image or a Docker container.
Okay, so you could use Packer to build your Docker container, which runs your Jenkins server,
Right.
which then outputs that useless jar that you need.
Right.
Keep that 10-year-old accounting software working.
Oh, but we can't afford to replace it, right? Just containerize it and put it up there in the cloud. That'll take care of it, right? It's in a container and it's in the cloud.
It's
Two things we need.
Frozen in time.
Two things that I think of when I think I want my money on someone else's hardware.
Exactly.
It runs on Red Hat 9.
Oh.
Actually, I ran
Go back to the
For
first version
years.
of Ubuntu. Let's put it on that.
I ran Red Hat 9 for years. Servers, 2 servers at work. That was years ago.
So to sum this all up then, Packer uses HCL code to spin up, set up, and package machine images. Just that. And there are a lot of platforms supported. AWS EC2, Docker, VMware, and a lot more. Key takeaway being write once, build everywhere. How simple is this to use, you might ask? I will show you in a very lightning quick example because we're running a little bit over time here. I'm going to show you a very quick
There's a shark in the middle of the fruit.
demo.
Oh, he's made out of a cucumber or zucchini.
I actually made one of those for my fiance a little while ago.
Where did you find that? Oh gosh, it's
demo
the
time?
Bible Life font, isn't it?
That's
I just Googled a picture. I don't know what that is.
I was like, where did you put a laundry detergent font?
Good point.
Billy Mays here for Packer.
Hi, Billy Mays here. If you call right now, I'll triple the offer. 3 VM builders for the price of 1. And Mighty Putty.
Didn't know he presented a bunch of charts, did you?
Nope. I miss Billy Mays. Okay, so we've got a Packer project here that builds a Docker container image that has Terraform and TerraGrunt installed, 2 tools that I use for automated infrastructure deployments in GitLab. There we go. So I've got a couple of different files here. I've got the variables defined in my variables PKR HCL. I've got my source, the Docker stuff, in source.pkr HCL, and the build process in build PKR HCL. And under this provision shell folder, I've got a shell script and a file to copy over, what we saw before, the SSH key pair, and I got my shell script there. So you can build a Packer image running 2 commands. It's as simple as that. We're going to start by running Packer init. We're going to give it a path. We're in the path, so we're just going to do Packer init dot. This causes Packer to analyze your code and see if you need any certain plugins, like the Docker plugin, the VMware plugin, and it'll download and install those and cache them locally.
So it'd be like more like staging for the build.
Yeah, basically. So we've got our plugins now, we've got our code. All we need to do now is build. And you do it with Packer build, we give it a path, and we're already here, so Packer build dot. This is going to fail, that is on purpose, just so you know, but I'm going to run it. So it's going to pull in the Docker image, it's going to copy over my file, we're going to run my shell script, it'll tag it, and it will try and push it, but fail poorly.
Now, do you have to run Packer in it?
Yeah.
So it doesn't. So if you don't run it, Packer build will not go. Oh, I see you didn't run this. Let me take care of the initial steps that you did not do.
Well, it's not that it won't do that, but it's a good practice to do that.
Oh, finished but no artifacts were created.
Right.
Something about certain build.
Right. I removed my Docker registry credentials from this because I don't want this to actually be deployed to my registry. So it failed on purpose.
Mhm.
So we can see here every step. We're pulling the Docker image up here. We're starting the container. We're provisioning with the shell script. We're uploading a file. And then, yep. We are going to kill the container, then run our post processors to tag the image, specify a repository, this whole big thing right here. And then we're going to try to push it. So that took 20 seconds to build, and even less time to run.
So if you're gonna fix your mix and fix, okay, I left this out, you have to start where you left off, or do you start from the beginning?
If your build screwed up somewhere, you start from the beginning.
Because it's a 20-second build. We're not talking 3 hours.
Right. Although it can take longer for certain other types of builds, like AWS EC2 instance or something on Google Cloud, Azure, or something like that. But that in a nutshell is Packer. If you're looking to build a machine image of any sort, including and especially Docker images, I would highly, highly recommend looking into it.
But then it's a Packer with Terraform, right?
No, this is just Packer by itself. It builds a Docker container that has Terraform, but it doesn't actually rely on Terraform itself. So,
Someone's escaping. Should we be worried? It's not related to your presentation. You just
Okay.
so any questions?
Questions?
Comments?
no, this is really
That's
cool.
pretty cool. Very good. Good.
Thank you all for being a generous audience. Thank you all. Good night.
Yeah.
Thank you for responding to the original question that we had before. Can you show us Packer? Because you showed us Terraform. So this is really cool.
Mhm.
Yeah, I'll have to show you all GitLab sometime.
Oh, GitLab.
Yeah, GitLab.
Oh,
Much better than GitHub.
It's only about one.
so what's,
Well, that's
is it
because-
similar
that's because
to
it doesn't have,
GitHub?
It's much, much better than GitHub.
well,
Yeah.
Because that's because GitLab didn't get Microsoft skilled into it, you know.
Oh,
Pretty
yeah.
much.
Well, yeah.
It's like GitHub, it's amazing.